In the last video, you learned about conditional probability, which is given by the following formula. So if we have the probability of an event B happening, given that event A already happened, this is equal to the probability of B intersection A divided by the probability of A. Now in this video, we shall use or we shall discuss the Bayes rule, which is also another way of finding the conditional probability. And this is especially used now whenever the intersection between B and A are not given, and as well as if we cannot find the probability of A. So before we dig into the Bayes rule, we shall define first or describe what is a partition of a sample space. So let S represents a sample space. The set of events B sub 1, B sub 2, up to B sub k constitutes a partition of the sample space S if the union of all the events B1, B2, up to Bk is equal to the sample space S. And the intersection of any two events B sub I and B sub j is empty. So we can actually think of this as a Venn diagram wherein the rectangle represents the sample space S. So the partition is that we're going to divide this rectangle into several rectangles that would represent the events B1, B2, up to B sub k. So if you get the union of the elements of each of these events, then the union will be the sample space S. And observe that each pair of events B sub I and B sub j do not have elements in common. So next will be the total probability rule, which is actually used in the computation of the conditional probability using the Bayes rule. So in this rule, in the total probability rule, we have a partition of the sample space S, and the partition would be the events B sub 1, B sub 2, up to B sub k, such that the probability of each event B sub I is not equal to 0. So that means that the events B1, B2 up to Bk will actually happen with a certain probability. Now, for any event A in the sample space S, we have the probability of A as the summation of the probabilities of the intersection of each event with the event A. So in the Venn diagram, if this is the sample space S and these are the partitions, B sub 1, B sub 2, up to B sub k, we have a we have an event which we call event A. So if you want to know the probability of event A, it is actually the summation or the sum of the probabilities of the intersection of each partition with the event A. So in this case, P of A can be written as the probability of B sub 1 intersection A plus the probability of B sub 2 intersection A plus up to the probability of B sub k intersection A. However, if the intersection or the probability of the intersection of each partition with A is not given, then we have to apply the multiplicative rule, which is learned from the previous video. So you can actually replace each of these probabilities of the intersection with the probability of B sub I multiplied to the probability of A given B sub I. So in this case, this formula here can be now written as the probability of B1 multiplied to the probability of A given B1 plus the probability of B2 multiplied to the probability of A given B2 plus and so on and so forth up to the probability of B sub k multiplied to the probability of A given B sub k. So we call this formula here as the total probability rule. And this formula will be used in the Bayes rule, which is in the next line. So what is the Bayes rule? So the base rule is actually a formula to find the probability of a condition. So in here, we have the probability that B sub R will happen given that event A already happened. So using the conditional probability formula, we have the probability of B sub R intersection A divided by probability of A. But as I have said earlier, that in base rule, that this quantity and this quantity may not be given in the problem. So which means you're going to apply the multiplicative rule. So this one here, using the multiplicative rule that you learned in the previous video, will be the probability of B sub R multiplied to the probability of A given B sub R divided by P of A, which is actually equal to the summation of P of B sub I times P of A given B sub I. And this thing here is actually the total probability rule. Okay, so let's illustrate this with an example. In a manufacturing plant, two machines B1 and B2 make 55% and 45% of the products respectively. So in this scenario, the sample space is the set of all products produced by the manufacturing plant. And in order for them to produce these products, they are using two types of machines. They use machine B1 and machine B2. And from the given, it says that 55% of their products are produced by machine B1 and 45% of their products are produced by machine B2. So this shows that the products created by B1 and B2 constitutes no a partition of the sample space S. Now also, if a product is made by machine B1, the probability that it is defective is 2%, while if a product is made by machine B2, the probability that it is defective is 3%. So there's another event which represents all those defective products produced by the manufacturing plant. So in our Venn diagram, we can have an event A inside the rectangle, which constitutes the defective products. Okay? So in here, the statement if a product is made by machine B1, the probability that it is defective is 2%. So this statement tells us that the probability that the product is defective given that it is made by machine B1 is 0.02, while the next statement represents the probability that the product is defective provided that it is made by machine B2 is 0.03. So in our first question, we're looking for the probability that the product chosen is defective. So which means we're looking for the probability of A. But this product, of course, is not given in the problem, so we shall use the total probability rule. So using the total probability rule, this is equal to the probability that um, we have B1 intersection A plus the probability of B2 intersection A. But we don't have any information about these quantities, so we shall use the multiplicative rule. So the probability of B sub 1 intersection A will be replaced by the probability of B sub 1 multiplied to the probability of A given B sub 1 plus the probability of B sub 2 multiplied to the probability of A given B sub 2. So now we have information about the probability of B sub 1, which is 55%, and the probability of A given B sub 1 is 2% or 0.02. The probability of B sub 2 is 45%, and the probability of A given B sub 2 is 3%. So we shall solve this in the next slide. So we have P of A as 0. 0.55, sorry, 0.55 multiplied to 0.02 plus 0.45 multiplied to 0.03. So the product is actually, or the sum of the products will be the value of P of A. Okay, so I'm going to compute this first, so please give me a few seconds. All right, so this is equal to 0.0245. Okay, let me check again. 0.55 times 0.02 is 0.011. And then we have 0.45 multiplied to 0.03 is 0.0135. And then adding those two products, we get 0.0245. Okay, please remember this because we're going to use this value in the next question or in the follow-up question. Okay, so now the follow-up question says if a product chosen is defective, what is the probability that it was made by machine B1? So we're looking for the probability that the product is made by machine B1 provided that it is defective. So again, this is conditional probability. Okay, so using the base rule, the probability of B1 given A is actually equal to the probability of B1 intersection A multiplied to P of A. But the probability of B1 intersection A is the probability of B1 multiplied to the probability of A given B1. This is using the multiplicative rule. And then the P of A here in the denominator is actually obtained using the total probability rule, which was already solved in the previous slide. And that value is 0.0245. So in the numerator, the probability of B sub 1 is 0.55, and then we multiply it by the probability that the product is defective given that it is created by machine B1, and that's 0.02. And then we divide it by 0.0245. So using again our calculators, we get 0.55 multiplied to 0.02 and then dividing it by 0.0245. And the probability when rounded off to 4 decimal places is 0.4490 or 0.449. So this is the probability that the product is made by machine B1 given that it is defective. Okay, so this ends the discussion about chapter 5, which deals with probability.